Hi friends, my name is GVK and I am going to discuss about the trigonometric ratios and how to define the trigonometric ratios when the terminal side lies in the third quadrant. Now we'll see. Let us consider the coordinate axis. As we know, this is positive x-axis, this is positive y-axis, this is negative x-axis, this is negative y-axis. Positive x-axis, this is positive y-axis, this is negative x-axis, and this is negative y-axis. The intersection of these two is origin. Now, if OX rotated in anti-clockwise sense and reaches to third quadrant, that is when the terminal side lies in third quadrant, something like this, that is the terminal side. This is the terminal side. Now, how to define the trigonometric ratios when the terminal side lies in the third quadrant? First of all, we have to form a right angle triangle in the third quadrant. Is it or not? Let us consider a point P and draw the perpendicular to the x-axis, here the negative x-axis. In fact, that is this point B, let it be some C. Let OC be negative of x again. Is it or not? And this value P will be negative of y, because here x is negative and y is also negative in third quadrant. Now it's clear or not? Now, angle of reference. What is the angle of reference? The angle of reference or the acute angle made by the terminal side with the negative x-axis here is purely this one. Therefore, the angle of reference is clearly theta, and the side which is opposite to theta is called as the opposite side, and this is called as the adjacent side, and this is called as diagonal or hypotenuse. Now what about this? Negative of x, negative of y, diagonal, that is negative of x whole square, negative of y whole square under square root. Again, x square plus y square, purely positive. Let it be some r. Now this OP value will be r. Now, this OCP is a right angle triangle, and which is called as the triangle of reference, and theta is called as the angle of reference. In fact, acute angle made by the terminal side. Now, we will define all the trigonometric ratios when the terminal side and the angle of reference are in the third quadrant. Now, sin theta. Sin theta is equals how much? Opposite side by hypotenuse. Is it or not? What is hypotenuse? What is the opposite side over here? Negative of y by what is the hypotenuse? R. This is negative y by r. Now what about cos theta? So cos theta is equals how much? Adjacent side by diagonal or hypotenuse, that is negative of x by r, negative x by r. Now what about tan theta? So tan theta is equals opposite side by adjacent side, that is negative of y by negative of x will become positive y by x. What about cot theta? The cot theta is equals reciprocation of tan theta, that is x by negative of x by negative of y, that is x by y. And what about secant theta? The secant theta is equals reciprocation of cos theta, that is negative of r by x, negative r by x. And what about cosecant theta? So cosecant theta is equals reciprocation of sin theta, that is negative of r by y. Here we can observe that sin theta is a negative, cos theta is a negative, tan theta is positive, cot theta is positive. This is secant theta negative, cosecant theta is negative because the final line, the OP, is present in third quadrant and angle of reference is also in third quadrant, or the acute angle made by the terminal side with the x-axis is in third quadrant. Therefore, in the third quadrant, tan theta and cot theta are positive, remaining all trigonometric ratios are negative. Now it's clear, right?